Hello everyone, welcome. And in this particular video, we are going to talk about inter-service communication with Spring Boot applications and microservices. Okay, so that is what we are going to cover. Now, when we talk about inter-service communication, it's one of the crucial aspects of building large scalable applications. So whether you're building any such small application or you're building application for $1 billion business. Okay, inter-service communication is going to be really important, and you need to understand how things work. Now, there are different ways of doing inter-service communication. Like, for example, you have RestTemplate, RestClient, WebClient, you have OpenFeign, HTTP interface, and like out of these, like few of the ways have been introduced in the new and latest versions of Spring Boot. Okay, so it's important that you are up to date as to how you can make use of these methodologies to do API calls and to do communication. So what we are going to do is what to expect. We are going to learn everything hands-on. So I'll give you an overview of what every way or what to expect over here. Okay, so what to expect when you're making use of RestClient and all. And we will actually implement RestClient, WebClient, OpenFeign, all of these methodologies in a hands-on way. We'll create two projects wherein we will have some data to exchange. So that will give you a gist. I believe hands-on learning is one of the best ways in which you can learn things faster. So that is what, and with this knowledge, you can take this knowledge to your production grade applications. That is what we are going to do. Okay. So I hope you are excited about this, and yeah, if you love this kind of in-depth content that I'm bringing to you all, you should definitely hit like, subscribe, and also comment below to let me know where you're joining in from, who you are, what you do, and what sort of videos you would want to see on this channel. Okay, that will help me with some roadmap and also some insights as to what you all are looking for. Okay, so without a further ado, let's jump right in. One small thing before we move forward, I want to give you an overview of my course, another course that exists. Okay, and if you're finding this content valuable, you will definitely love to check out this particular course. This is a Spring Boot microservices course wherein we build an e-commerce application using microservices architecture. Okay, and it's a 55-hour course currently as I'm recording this video, and I'll be adding more number of hours into this particular course for sure. So people who have enrolled into my courses or who take my courses regularly, they know that I keep adding content. Okay, now what is different in this course and why you should take this course? So first of all, I'll tell you, this course sells on Udemy. This course is hosted on Udemy. So if you click on the enroll button over here, you will be taken to udemy.com with the lowest price possible at that point in time. Okay, now I don't control the pricing over here. Udemy controls the pricing, and Udemy sells this course. So there are two ways to get this course. One is you pay a certain amount and get a lifetime access. Another way, this course is part of Udemy for Business catalog. So you can see over here, it's part of Udemy for Business catalog. And if you have your company's Udemy for account, Udemy for Business account or subscription access with you, then you can enroll in this course for absolutely free. You don't have to pay anything. Okay, so that's the course over here. You can see over here right now it's 56.5 hours as we are filming this video. If you scroll down, you'll see first we begin with the monolithic application. So here in the first part of the course, for around 5-6 hours, I cover how you can build an e-commerce application in the monolith architecture. And then what we do is we transition. So here you can see microservices section starts. We begin talking about different databases. We restructure our application. So this is where we start restructuring our application into microservices, and we convert a monolithic application to that of microservices. So I start splitting services, and this gives you a good understanding of today. If you have your company, if you're working somewhere, okay, and if you have a monolith application and you are not able to scale, so your boss might ask you like, hey, let's switch to microservices architecture, and you have the knowledge over here as to how you can transition from monolith to microservice. So that is important. Okay. I teach you different databases. So in microservices architecture, you get the liberty of making use of different databases. So MongoDB, MySQL, PostgreSQL. I show you everything hands-on way, step by step. Okay. We talk about configuration management. Now, there are a lot of things taught in this course, okay, that are not taught anywhere else. For example, this section on configuration management is just 5.5 hours. It's a course in itself. It's a separate course in itself. So I teach you a lot of stuff. You can see over here, different ways of managing configuration, how you can host your configuration on GitHub, how you can host your configuration in a private GitHub repository. All of that is taught over here. Okay, you can see everything. Okay, it's totally in depth, no fluff. I teach to the point, but still it's 5.5 hours. Okay, I could not reduce, but that's okay. We are learning production grade techniques, and you can implement a particular way of managing configuration depending on your project. So I teach you all of that. Then inter-service communication, it's totally in depth. You can see service discovery, totally in depth. We make use of different REST clients that are available. These are modern REST clients that exist. So I teach you all of that. Then I have observability section, which goes on for almost 4 hours. Okay. And I teach you how you can implement observability using Grafana. So we make use of Grafana, and I teach you how you can monitor logs, metrics, and tracing using Grafana. Okay. And we also cover Zipkin. So that's something we have. API gateway. So we talk about API gateway, how you can make use of Spring Cloud API gateway. Then we have, so we have fault tolerance as well. And there are a lot of sections coming in. And then we have another project over here, which is a job application. So here we have a Docker Kubernetes also covered. Okay. So this is a complete package with a future roadmap. So if you come over here on the website and you check this roadmap, this is a roadmap as to how I am going to update this particular course. So there's a lot coming. Front end is coming in. You have a deployment section. You have security deep dive. Now, security is not like I cover just one thing. I'll show you different scenarios in which security can be implemented. You'll be learning production grade techniques. That's the difference. Okay. So it's very in depth for serious learners, and it sells on Udemy. So I don't need to tell you the price point at which Udemy sells courses. Udemy sells courses which are very affordable. I could have hosted it on my own platform, but I believe in affordable education, and that's the reason why I have it hosted on Udemy. Okay, so just to give you a gist of the price in India that it sells at is below 500. So you will easily get it for below 500 INR. Okay, in India. That's really cheap, I feel, compared to the value that this course delivers. And outside India, you will get it below $15. So sometimes the price is $12, sometimes it's $13, $14, but below $15. Okay, and that's the value. Okay, and it's very highly rated. You can see. Now this is microservices. We are making use of microservices architecture to build an e-commerce application. I have one more course. Okay, which is this one. I have it open in the tab. This is again hosted. You can see this is the landing page, and it's hosted on Udemy. Okay. Now this course, what is difference? What is difference in this course and this course? So this course also we are building e-commerce application, but we are learning Spring Boot while building e-commerce application. This is on this other course that I just spoke about. This is microservices architecture. So I assume that you know a lot of Spring Boot. I touch upon Spring Boot, but I don't go into depth, because that's not the motto of the course. Okay, if you're learning microservices, you should be aware of Spring Boot. But yes, we do brush up some concepts. I teach you how APIs work and all. Little bit of brush up we do, but in this course, that is the other course, here we are building a production grade e-commerce application using Spring Boot monolithic architecture, along with a production grade technique used, and we are building React front end as well. Okay, so this is very much in depth if you are looking to learn Spring Boot and build a portfolio project for yourself. Like the e-commerce application we build is very much complex. We handle a lot of complexity. So you can see over here, like cart management, order management. There is payment integration using Stripe as well, validation, sorting, searching, all of this, deployments, and it's 85 hours long. Okay, so if you click on this and if you go over here, you'll see like it's the category bestseller right now. Okay, a lot of people have found value with this course. It's 4.6, 4.7 star rated, and almost 90 hours, 89.9 hours. So it's very much in depth. I would encourage you to check out this course. So if you don't know front end, it also teaches front end. You can see over here. So first we talk about a Spring Framework. It starts with Spring Framework. Then we talk about GPA and Spring Boot. Then we talk about advanced things like security, managing user profiles, custom authentication, how you can customize security. That's really important. Okay. How you can manage shopping carts, different databases, manage user addresses, orders and payments, all of this, Stripe integration. We do all of this. We deploy the application. When we deploy the backend, and then we switch about front end. We switch talking about front end. So I teach React first. I don't directly jump to front end. So we learn React, and I have tagged lessons like React Beginner, React Intermediate, React Advanced. So depending on your level, you can pick the sections, and then we start building the front end as well. And we make use of complex topics in React like Redux. So all of that is covered as to how you can manage front end and how you can improve on it. Then you have some AI related applications. I have some few projects in the end as well. How you can deploy your application for free. So these are some useful sections that exist. Okay. And then the course has the job application. So this is the older version of the course, which students requested me to have. Okay. But the course is really comprehensive. It's totally in depth and totally worth it is what I would say. Okay. And yes, you can also take a look at the live application demo or check out the preview videos over here on the landing page itself. Okay. It should have the application demo. So this is something, this is the difference between two courses that I just told you. One is using microservices architecture. One is using monoliths. But yes, we cover a lot of features of Spring Boot. So if you are learning Spring Boot, or even if you are an advanced level developer, you will still get value from this course. Okay. There are a lot of things that are covered which are not taught everywhere. Okay. And it's all based on my personal experience. So that's something that I'm sharing over here. And you can take a look at this, and you can find a lot more over here on embarx.com. Okay, so this is the course that I was talking about. This is the microservices course. I have Spring Security course. So there is a Java programming course as well, and there are tons of courses that exist. So you can just explore this website. Okay, I'll leave links to these courses that we spoke about. Okay, and you can basically go through everything in the description below. Okay. But I would like to tell you, like, these courses are not expensive. Okay. Trust me, if you build something valuable in your portfolio, you get a job. Okay. If you're a fresher, you might land your first job. If you're experienced developer, you might get a better job. So it's not like I'm experienced and I don't need to create my own portfolio of applications. I truly believe if you are a developer, you should have portfolio projects. You should have portfolio up there. And you should showcase that this is what I've built personally. Yes, this is my experience. I built this for the company. But apart from learning and working for the company, I have my own personal projects using Spring Boot. That adds a lot. That adds a lot, So this differentiates you from the other people who are interviewing for the same job. Okay, because you also have your personal projects. Yes, you're working for the company, you're also building your personal projects. So that is what distinguishes you from others. So that's something that I'll tell you. Keep building projects, and I would tell you, learn publicly. You should post on LinkedIn that, hey, I am following this, I'm building this, I built this application, deploy it. I cover how you can deploy for free, including front-end, back-end, and database. You can deploy your application for free. So that is valuable, and these courses like these help you do that, and the job you get pay you a lot more than you spent on these courses. So you are hardly spending anything, so $500 in India and $15 abroad, like outside India, is not a lot compared to the value it delivers. So that is something that I'm saying, and it's a fact. You can go check out the reviews of my courses as well. Okay, so enough of this. I think we should move on to next. I hope you have got the point over here. All right. So now it's time that we talk about inter-service communication in microservices. So what is inter-service communication? Now, inter-service communication is a way wherein different services in a microservices architecture communicate with each other and they share data with each other. Now think of it this way. So here you can see in diagram we have multiple services running. Now here I have an example wherein I have 3 microservices, only 3. Now in real world project, these number of microservices would be much higher. And you will have someone like here I'm showing browser that is trying to access the API, or you might even have a front-end application from the browser, or you might have a mobile app. So anyone can access the REST API, and each microservice has its own database. Now, when different microservices are running, they run in their own process and they have their own memory space, they have their own functions, and they can call those functions or methods directly, right? Now, there will be a need wherein you might want to communicate to different microservices to get some data, to validate something, to fetch some user information and all of that. And that is where inter-service communication becomes really, really important. Because you can see over here, for the end user or the client who is making use of these services, he's an external party, right? He's someone from another organization or he's an end user. So for them, the system should function as one single unit. Okay. Now, if you compare this with monolithic architecture, you will understand the importance of inter-service communication. So in monolithic architecture, components of an application share the same memory space and they can call the functions or methods within the application directly, right? And there is no need of having an inter-service communication when you are working on a monolithic architecture application, right? However, in case of microservices architecture, each service has its own memory space and runs in a separate process. There might also be different servers. So for one service to talk to another, they need to serialize the messages to a common format and they need to send them over the network, making inter-service communication a fundamental part of the microservices architecture. So this is about microservices, and that is why inter-service communication becomes really, really crucial. So talking about why inter-service communication is important. So you must have got a gist of why it's so important. Take a look at end user. Now, end user or any external party who is trying to make use of your application that is built using microservices architecture. So for him, the application is providing the needed output, and for him, it's not like there are multiple services running. He should not be aware of what services are running behind the scene in the backend, right? For him, your application is functioning as a single cohesive system, right? And for him, he should not be aware of any backend stuff. So this is where inter-service communication becomes really important, wherein you need to facilitate collaboration, data sharing. So collaboration, as in most real world application, I mentioned like most real world application needs services to work together. For example, if you're building an e-commerce application, you might have cart service separate, product service separate, user service separate. So for placing an order, all these 3 services need to work together along with the payment service, which is also a separate microservice, right? So in this case, there has to be some really good collaboration, right? And this can be done using inter-service communication. Also, any sort of data sharing, for example, if you're placing an order, then who is placing the order? A user is placing, right? So is that user valid? Does that user exist in the system? So all these kind of validation things can be possible using data sharing. And microservices aim to decouple the functionality, but to maintain the overall system's coherence, these independent services must communicate efficiently, and that is why inter-service communication becomes really, really important. And inter-service communication also, one more thing, they enable systems to scale horizontally. Okay, they enable a sort of isolation. So, for example, you might have 10 services running in an e-commerce architecture, right? One for product, user, order, cart, payment, notifications, and so on. So, if one service fails, others can continue operating, functioning independently, or retry the communication, right? But in case of monolithic, if one fails, everything fails. So that's the benefit. And inter-service communication makes your system look like one cohesive system that is working towards a single goal of serving the user. I hope this is making sense, and I hope this is clear. I'm trying to be as explicit and as simple as possible. Now, talking about how can you implement inter-service communication. Now, there are a couple of ways in which you can implement. First way is you can do synchronous communication, right? So microservices can communicate with each other using synchronous request response mechanisms, wherein the client who is calling another service waits for a response from the server before proceeding to the next step, right? and this can be achieved using HTTP based protocols like REST or SOAP, right? So you can do synchronized communication, and then there is another kind of way which is called as asynchronous communication. Now you can communicate, or the microservices can communicate between each other asynchronously by using message queues or message brokers like RabbitMQ, Kafka, or cloud-based queues like AWS SQS. So there are different services to enable this happen. And what happens over here is the sending service publishes a message and the receiving service will consume when it's ready to consume, right? So it's completely asynchronous, wherein the sending service won't wait for the response from the other service, and it will just continue doing its other task. So that's these are two ways of implementing inter-service communication. One is synchronous, another one we have is asynchronous. Now synchronous, like you can gauge from its name, it's basically tightly coupled. There is a bit of angle of tightly coupling over here, wherein if one service is down, the communication could fail, or there could be some sort of higher latency due to waiting for a response. So that is one thing to keep in mind. And regarding asynchronous over here, asynchronous is basically asynchronous. The other service is not waiting, but there could be some additional complexity in managing message brokers and managing consistency. It could be harder to debug or trace the flow of events. So all these challenges comes into picture. Okay, so there are pros and cons, and depending on your requirement, your needs, you have to pick up the right way to implement it into your microservices architecture. I hope this is much more clear, and I hope you are clear as to what inter-service communication is and how to implement it into your microservices network. So now is the time that we talk about different ways of doing synchronous communication in microservices architecture. Now, of course, there are different ways of doing this, and we'll take a look at every way and we'll try to understand each way. And in the process, I'll also talk about the evolution of inter-service synchronous communication in microservices architecture, because this will help you understand as to how things happen in the early days and now what are the developments that have happened, and this will enable you to also make the right choices. Okay, so let us talk about different ways. So different ways include making use of RestTemplate. You have something called as OpenFeign that you make use of. You have REST clients, you have WebClient, and then you have HTTP interfaces. Okay, so these are the different ways in which you can do synchronous communication in microservices, right? Now, if you're not aware of any of this, don't worry. We'll take a look at each and every term and we'll understand this. Okay. Now, before talking about each and everything over here, let's dive into a bit of history and let's understand how the communication methods have evolved over a period of time. This will help us understand as to how development has happened. Okay, and we'll talk about the early days first, wherein the manual HTTP calls and low-level clients were being used. Then we'll talk about the client-side load balancing and service discovery as to how that was introduced. And then we'll talk about declarative HTTP clients like OpenFeign and beyond. And then we'll talk about other HTTP clients that exist today. Okay, so let us first talk about the early days wherein like manual HTTP calls and low-level clients were being used. So in the initial stages, services communicated using HTTP clients, as you can see, like Apache HTTP client or even raw socket programming. And this required developers to manually handle request creation, response parsing, error handling, and retries. So it was, as you can imagine from this brief itself, that was a very manual and a very primitive approach is the right word. So that is what it was. Okay. Then things evolved, and as microservices became more popular, Spring introduced something called as RestTemplate. Okay. Now, what does RestTemplate do? The RestTemplate was like an abstraction that simplified making HTTP calls by providing high-level methods like get for object or post for entity. Okay, so it provided these methods, and while still being imperative and synchronous, it did a lot of benefit to the developers out there. Okay, and it abstracted a lot of boilerplate code from the developers, but it still required explicit configuration for aspects like timeout, error handling, manual integration with client-side load balancing, and so on. Okay, so this was Spring's REST template. Spring REST template, let me tell you, it's being used widely even today. Okay, so this is how Spring REST template comes into picture after direct HTTP clients usage. Okay, and if I have to talk about Spring's REST template, this is how you would do an API call normally in Spring's REST template. So you can see over here, this is a code over here. Okay, and what we are trying to do over here is we are trying to make an API call over here. You can see I have the object first created of REST template, and then I'm making use of REST template object, and I'm calling this method over here, get for object. So this get for object method is provided to us by REST template itself, and then you pass in the URL over here. Okay, and you mention the class. So you get the response as a string, which you are holding over here in the response object over here. Right? So it was introduced in Spring, like I said, for simplifying REST calls, and you can see it makes use of methods like get for object or post for entity. Right? So these are the methods that it will make use of, and it is very ideal like for straightforward blocking HTTP interactions, right? And it's a synchronous client with template method API. You can see over here, this is how you would normally make use of Spring's REST template. Now talking about the next phase over here. So next phase involves the introduction of client-side load balancing and service discovery. So this came into picture, and there we could hear terms like Eureka. So there were some issues like service instance management. So if there are multiple instances of a particular service, how would they be managed? There was also a concept of fault tolerance. So if a service fails, how would you make microservices resilient? The entire network should not crash, or there has to be some sort of fault management over there. That is what fault tolerance is, right? So when these things started coming into picture, things like Ribbon, okay, Netflix OSS components like Ribbon for client-side balancing and Eureka for service discovery were integrated with REST template. And this made inter-service communication much more resilient, dynamic, and it started allowing calls to automatically distribute among available service instances. So all of this was possible when Eureka was introduced. Then after this, there was a need of declarative HTTP clients like OpenFeign. Okay, now what is OpenFeign? So here, OpenFeign basically was introduced after recognizing the repetitive nature of REST call boilerplate code. Okay, so there was a lot of boilerplate code that was generated when making use of other methods like REST template. And hence something like OpenFeign was brought into picture. So OpenFeign is a declarative client over here that emerged, and with OpenFeign, developers can define a Java interface and they can annotate it with Spring MVC with basically annotations. So they can make use of annotations, and this is something similar to like controllers that you define today in Spring Boot, right? So you just annotate, and then they are mapped to a request. So in a similar way, with OpenFeign, you define an interface, you map it to a request using the annotation, and you can just do remote API calls by calling those interface methods. Okay, so that is what OpenFeign did. And with OpenFeign, code was much more simplified. You had less boilerplate as a framework generates the underlying HTTP client logic. And the integration was really good. So there was a built-in integration with service discovery, like Eureka server. And this made service calls much more seamless. Okay, so all these sort of benefits started popping up, and a lot of developers started preferring clients like or ways like OpenFeign over here. Okay, so you can see over here, this is an example wherein we are doing an API call using OpenFeign. So you can see over here, I have a interface. You can see this is an interface. It's a interface, and here I have string get resource, and I have this get mapping, and I'm mapping this to this particular URL. Now, which server is it calling over here? So you can see over here, Feign client. I have added this annotation again, Feign client, and I'm making use of name over here, which is example service, and I'm specifying the URL. So basically, if you want to call http example.com/API/resource, you have to just call get resource from this interface. Okay. Once you do that, an API call is triggered. So it's like calling a Java method in your code, you are not calling a REST API. The syntax you will write in your Java code is just like you are calling any other method in Java, right? And then the request will be made basically to this particular URL there. Okay, so this is the declarative approach for HTTP clients for REST API. So you are creating a client basically for example service over here. Okay, so you can also call this interface as example service client for easy identification in your project, or example Feign client. So right now it's being called as example Feign client. Okay, so this had a built-in support in Spring Cloud for declarative REST calls, and this still has reduced boilerplate code, integrates service discovery, supports resilience patterns, a lot of stuff. Okay, now let me tell you, OpenFeign today as well, it's quite popular. So even RestTemplate is being used a lot. OpenFeign is also quite popular, and it's being used in a lot of projects. So if you are working on a production grade environment, or if you're planning to, it's likely that you might see some code written in Feign client, or using Feign client, or using RestTemplate. They both are really popular. Okay, so this is about declarative HTTP client like OpenFeign. I hope this makes sense. Now, after this, what happened is there was an introduction of new REST clients in Spring, and there were 3 REST clients over here. So we spoke about RestTemplate, we spoke about OpenFeign. Okay, I showed you the example for both as well, and I showed you how things have evolved from to RestTemplate, and then from RestTemplate to OpenFeign. Now let's talk about the new REST client. So there are 3 things that we are going to talk about. One is the REST client, then I'll talk about the WebClient, and then we have the HTTP interfaces. Okay, so let us talk about each one of them. So the first one we'll talk about is the REST client. Okay, WebClient I'll talk about. So what is WebClient? So WebClient is basically introduced in Spring 5 Webflux, and it was introduced for asynchronous operations. It's a non-blocking reactive client with Fluent API. Okay, it supports reactive programming and integrates well with Mono and Flux, and this is ideal for high throughput application. And here is where you can see the example of WebClient. You can see over here, I've created an instance of WebClient over here using webclient.create, and you can see over here, this is the URL, and then I'm getting the response over here. You can see webclient.get. I've mentioned the URI. So this URI is on this host, and I'm saying retrieve, and I'm making use of body to mono and getting it as a string.class. So that is what I'm doing over here. Next client we have is the REST client. Now REST client was introduced in Spring 6. So Spring version 6 is what I mean over here. It's a synchronous client with Fluent API, and it's a modern alternative to RestTemplate. Okay, and it provides a Fluent API similar to WebClient, but also remains synchronous. So here is how you can make use of REST client. It's much more similar to that of WebClient, and you can see over here I'm creating an instance of REST client first by passing in this host URL, and then I'm specifying the path, and then I'm making the call over here and getting the response over here. Okay, so this is about REST client, and then you have something called as HTTP interface. Now what is the HTTP interface? So it's an annotated interface with generated dynamic proxy implementation. Okay, so it's like a proxy basically. You can create a proxy basically to WebClient, and you can even make use of REST client over here with HTTP interface. And it is similar to OpenFeign, but built into Spring 6 Plus without requiring Spring Cloud. And it makes use of this annotation HTTP exchange to declare REST clients in a declarative way. Okay, so you can see over here, this is a much similar code to that of OpenFeign like we saw over here. And you can see over here, HTTP exchange URL is this one, method is this. So you're specifying the URL and method, and then you are specifying the client over here. Okay, so this is how you are specifying. Now you can make use of this particular client that you have created with WebClient or like the REST client. Okay, so it helps you reduce your boilerplate code, and it helps you create a proxy. So that is what it does. So I hope you're clear about different ways of doing synchronous communication with respect to microservices architecture. Now it's okay if you have not understood everything, but when we take a look at examples, everything will be much more clear to you all. That is something that I can promise. Now I just wanted to give you a quick overview of which REST client does Spring itself recommends. There are so many REST clients. Which one should you choose and what would Spring recommend? And yes, here I am here on the official website of spring.io. You can see, just go to projects over here and just click on Spring Cloud. Okay. And here under Spring Cloud, you will see, if you scroll down, Spring Cloud OpenFeign. So if you come over here, Spring Cloud OpenFeign is one of the most popular thing out there, and it is being used in a lot of Spring Boot projects. Okay. Now if you scroll down over here, okay, we don't see anything over here, but go to Learn and just click on Reference Doc over here. So if you click on Reference Doc, you will be taken to the documentation over here, and you will see over here, this project provides OpenFeign integration. So it's to talk about OpenFeign, and it gives this warning over here. So it says, as announced in, okay, I'm sorry. So as announced in Spring Cloud 2022.0.0 release block entry, we are now treating Spring Cloud OpenFeign project as feature complete. Okay, which means there will be only bug fixes that will be done, and no new releases or no new features will be added into this particular library over here, or the OpenFeign over here. Okay, so Spring itself is recommending that you switch over or migrate over to Spring interface clients over here. Okay, now I'll show you what this blog entry is. So I'll open this blog in new tab. Okay, I have it open over here as well, but I'll open this one. Now here, if you see, you can see this is a blog entry for Spring Cloud 2022, and this is a date when it was published. And here, if you see, okay, Spring Cloud OpenFeign feature complete announcement. Okay, so you can see over here, Spring now provides its own interface HTTP client solution. Okay, and starting this version, we are going to treat OpenFeign as feature complete. This means that Spring Cloud team will no longer be adding new features to the module and will still fix bugs and security issues. Okay, so that's what they have announced over here. So if you're building a new project, and if you're considering OpenFeign, I would highly recommend that you switch over to the native or inbuilt HTTP client solution that Spring provides. Now, what are these native client solution that Spring provides? So here, if you see on Spring Cloud OpenFeign, you can click on this link over here. We suggest migrating over to Spring interface clients instead. So if you open this over here, you'll be taken to this link over here, which is for HTTP interface. And on the left hand side, if you see, this is the article for RestClient. So if you scroll up over here, you will see all the REST clients over here. So it was recommending HTTP interface. Okay, so if you scroll up over here, you can see the Spring framework provides the following choices to make for making calls to REST endpoints. And you can see over here, RestClient is one option, WebClient, RestTemplate, HTTP interface is also one option. So you have RestClient over here. Okay, and you can see over here, it's a synchronous client with Fluent API. WebClient is non-blocking asynchronous. It does not block the UI, and here you can see it's a reactive client with Fluent API. Then you have RestTemplate, which is synchronous client with template method API, and then you have HTTP interface, okay, which is basically for dynamic proxy implementation. Now, if you go to RestClient, you can see the examples over here for RestClient, okay, how you can make use of it. Okay, I'm just going to scroll through. So this is how you can make use of RestClient. Okay, a simple example, you can see it's setting up a GET request, specifying the URL, retrieve the response, convert the response to string, and print it. Okay. Now, if you scroll down further, if you go to WebClient over here, so WebClient, you can see it's a non-blocking reactive client. And if you scroll down further, you will have RestTemplate over here. Okay. So RestTemplate, you can see over here. If you scroll down here, you see a note. Okay. So it is telling that RestClient is offering more modern API for synchronous HTTP access. So please consider using that. That is what it's telling you. And here, if you come to RestTemplate official documentation, okay, this is the one. So here you can see a note as well. It offers. So they are pushing everyone to basically, this is the article, to make use of, if you scroll up, to make use of RestClient, WebClient, and HTTP interface. Okay, RestClient, WebClient, and HTTP interface. Okay, that is what they're pushing you all for. Okay, so OpenFeign, like you read, it's feature complete. You can use it in your projects. Okay, they will still be doing bug fixes and all, but since Spring has openly mentioned this, it is recommended that you migrate to their native REST clients. Okay, so these three are the native REST clients, like REST client, web client, and HTTP interface. Okay, REST template is also there, but it's pretty old. You can make use of it. You'll see a lot of projects making use of REST template still today. So if you are working on a legacy project, you will still see REST template appear over there. Okay, and I'm going to talk about I'm talking about all these clients over here. Okay, because I don't want to miss out and leave any corner over here. Okay, you should know all of them. Okay, but if you're building projects today, I'm telling you what you should pick today. That is what I'm telling you. So if you scroll down over here, this is, so we spoke about REST template. Now this is the HTTP interface. So here you can see HTTP interface. You can basically create a proxy over here. So you can see over here, this is the exchange that you have created. Okay, using HTTP exchange methods over here. You're making use of HTTP interface over here. Okay, you can see this is how you have defined. And then you can use it with either RestClient or you can use it with WebClient. You can use it with both. Right? So that is what it tells you. You can even make use of it with REST template. Okay, so you can read the description over here. It lets you define your own HTTP service as a Java interface with HTTP exchange method, and you can pass such interface to HTTP proxy factory, HTTP service proxy factory, to create a proxy which perform request through HTTP client such as REST client or web client. Okay, so that is what it tells you. So here you can make use of it for REST client or web client, and it acts as a proxy. Okay, so these are Spring native clients that you should be aware of. Okay, and this update also you should be aware of about OpenFeign. Okay, so I'm just mentioning this explicitly because this is important, and if you're building Spring projects today, you should be aware of all of this information. Okay, so I have the same links open over here, but I hope this has been useful. So now let's talk about how we are going to have inter-service communication, and for that we will need a couple of projects, right? So that they can interact with each other. Now there are two services that I'm going to create. As you can see over here, I have consumer and then I'll have provider. Now provider is a service that is providing some sort of information, and that is why it's called provider. So the information that I'm going to provide from the provider is a very simple string over here, which I'm going to say like request is received on this particular instance, and this is a port, right? So we are going to return that via an API on provider, and consumer is going to call the provider for that particular information, right? And it is going to consume that information. So I'm keeping things really simple so that we can focus on learning and not on the complexity of the project. We need to learn inter-service communication using this project. Right? So I hope you are excited. So now is the time that we set up the consumer project and the provider project onto our system. So to save time, what I've done is I have accessed start.spring.io and I've selected the relevant configuration that we need for consumer and the provider. So let me take you through this. So here you can see I've selected Maven, Java, the latest non-snapshot version of Spring Boot. I have added the project metadata as com.demo, artifact as consumer. Now once you enter this information, the package name and everything else is generated automatically. Select jar and the latest version of Java that you see. Now select the dependencies as Spring Web and Lombok over here. We'll add any more dependency if we need later on. But right now these two are enough. And then for the provider project, in the another tab, I have Maven, Java, and this version of Spring Boot. And here I have com.demo, which is the same group as that of consumer over here. Okay. And I've mentioned artifact as provider over here. And the package name and rest of the information gets generated automatically. Select the relevant packaging and Java version. And then you can select these two dependencies like web and Lombok. We are selecting web because both these projects will have REST APIs. So we need Spring Web. And Lombok basically if we need to reduce any sort of boilerplate code. So that is what we are using for, right? Now I would quickly click on generate and I'll get the zip file for both these projects and I'll add it to the location where I want to work on these two projects. So as of now, you can see I've got the zip files onto my local system and I have moved them or I've downloaded them to my project directory wherever I'll be building this project. Now I'll quickly unzip both these files over here. So I'll just unzip both of them. You can make use of any software to do this. And I'll quickly delete these both zip files. Okay, so we don't need zip files. we'll just have the unzip version. Now, once we do this, we have both these projects ready to be imported into IntelliJ. So IntelliJ IDEA is the IDE that I'll be making use of. Now, what I'm going to do is I'm not going to navigate or open IntelliJ and navigate to the directory of this project. But in fact, I'll just navigate and open the parent directory where these projects are residing. So these projects are residing in InterService. You can see the location over here, InterService. So you can see the location over here, InterService is the folder name. That is what I'm going to open. So I'll quickly come to IntelliJ. I'll say open over here. And once I click open, I'll navigate to this InterService folder where I have unzipped versions of these two projects. I'll select InterService and I'll open these projects or this folder over here. Okay. Now InterService is not a project, but it has two projects inside it. And you can see over here a tip from IntelliJ that may well build scripts found. Do you want to load? So I'll say load over here. And the moment I say load over here, consumer and provider would be identified as Maven projects by IntelliJ. And you can see the dependencies for these two projects is being resolved over here. Okay. So things are in progress. You can see there is a dependency resolution step and you will also see Maven icon appear over here. Okay. So yeah, this is happening. We'll wait for a while until this finishes. But what will happen is both these projects are now Maven projects and we can work over here in both these projects. It provides us with a unified view as you can see over here, right? So after a while, you can see all the syncing related stuff and all the dependency downloading by IntelliJ is done. And we have these two projects now. And you can see over here in Maven, these two are identified as Maven projects. All right. So we are ready to work on our application. And what I will do is I will begin defining the controller over here in the provider. Okay, so we will add some code in consumer as well as the provider. So first of all, I'll head over to the application.properties file of both the applications over here. Okay, so I'll open it for consumer as well as the provider. Now in consumer, I'll say server.port over here. Okay, this will be 8080. Consumer port is 8080. And I'll copy this and I'll move this to provider and I'll say this is 8081. Okay. So here I'm making use of application.yaml format. Application.properties format. Sorry, this is not YAML. But if you want, you can switch over to YAML by renaming this particular files. Okay. So we have consumer running on 8080 now and provider running on 8081. They're still not running. We need to run them so that they could be running. Okay. Now I'll come over to provider and I'll head over to the main package. I'll say new. And what I will do is I will create a new Java class over here. Okay. And I'll call this as instance controller. I'll keep things really simple. Okay. We don't want to complicate things. And I will come over here. First thing we'll add is REST controller because this is a REST controller. Of course, I'll come over here and here I'm going to say get mapping. Okay. Get mapping over here. And I'll say public string, I'll say get instance info. So we are just returning the instance info using this particular endpoint and anyone calling this is going to get the system information. Okay. Now I'm going to add a system.out.println over here and I'm going to say request received on or at instance running on port over here. And we will be printing port number as well. Okay, so just hang in there and I'll say port over here. This port does not exist. So I'll say over here private string port, something like this. And here I'll inject the value for this using the value annotation. And I'm going to say $ over here. And I'm going to say server dot port, something like this. Okay, I need to close this round curly braces. Okay. So this is done. Okay. And over here, then we have this port number being printed. Okay. And here I'm going to return. Okay. So what am I returning? So I'm going to say instance served by, I'm going to say port over here. So I'm just printing in this information. Okay. And what are we going to print? We're going to just add the port information. So I'm going to say port. And I can even add instance information. Okay, so I'm going to say dot instance and I'll say, sorry, instance ID over here. So I'll say instance ID. Okay. Instance ID. Now this instance ID does not exist. So what I can do is I can simply add some instance ID, which will be private final string instance ID is equal to, I'll just add a random ID to uniquely identify the instance. So this is optional, not needed, but I'm just adding some sort of information over here. Java.util. There is a UID over here. You can say random UID, and I'll get this to string, something like this. Okay, so this is done now, right? And I'll have a URL over here. So it will be instance, sorry, so it will be something like this, instance info, like so. Okay, let us run this provider application. Okay, let me run this. Let us wait until it completely runs over here. So you can see the application is up and running, and you can see over here, I can see like no issues as such. Now I'll come over here, and here I'll say localhost colon 8081 slash, oops. So I'm going to say slash instance info, like so. And you can see over here, instance served by port 8081, and instance ID is this. This is a random generated unique identifier. Okay. So this is optional, but yes, you are seeing this, and here also you should see request received or something like that. 1 second. So we did print request received, initialized. Okay. All right. So we are not seeing system.out.println over here, but ideally we should, because we are printing this thing over here. So I scroll down and I could see this information over here. Okay, for the instance control over here. Okay, so this is working absolutely all right, and we have the desired output. So I hope you have been able to follow along, and I hope this has been useful. So now is the time where we are going to understand how you can make use of RestTemplate to do inter-service communication. So RestTemplate is a Spring class, or a class in Spring, that helps you make HTTP requests to external APIs or microservices from your Spring Boot application. Now think of it as a way for one application to talk to another application over the internet. Okay. Now over here, what I have is I have a couple of services. Okay. I have this provider service, which is running basically on port 8081. And then I have consumer that will be running on 8080. And provider has this controller, which is just providing the instance information. Now what I will do is I'll come over here to the consumer, and here in the main, like in the main package, I will create a new package over here. I'll say package, and I'll say RestTemplate over here. Okay, so I'll organize all my files under RestTemplate package. Okay, and what I will do is I will have a way over here for communicating using RestTemplate. So that is what I am going to do. And we will begin by creating a controller first. Okay, I'll say a controller over here, and I'll call this as RestTemplate controller. Okay, something like this. So I have this class now. Okay, and I'll come over here. The first thing you do in controller is mark this as REST controller. Okay, I will also add a request mapping annotation, and I'll map this entire controller to one specific endpoint, which is API slash, I'll say RestTemplate. Okay, something like this. And then I'll come over here. Okay, and I will create an endpoint over here. So I'll say get mapping over here, and I'll add instance. Okay, so this is the endpoint over here. Okay, and here I'm going to say public string get instance, something like this. Okay, so this is the method that will be called when you invoke this API. Okay, now this is returning a string. So what we have to do is we need to fetch the details from this particular controller. So this is the endpoint on localhost 8081. Okay, instance info. So we need to call this endpoint using RestTemplate, and we need to return the information. So right now I'll return something empty over here. There's no information, or I can say hi over here. Okay, so that we can at least see something. And I will at least start the service. so that we can see the service starting without any hassles. You can see the service is up and running. I will just copy this endpoint over here. So this is localhost 8080 over here. So I'll come over here, and here I'll say localhost colon 8080 slash this endpoint. Okay, and then I'll call over here instance, something like this. So you can see hi coming in over here. Now I want to call the endpoint from the other instance, which is nothing but the provider. Okay, so what we are going to do is we are going to make use of RestTemplate like we discussed. So I'll come over here. Okay, I'll just collapse this so that we get a better view. And here I'm going to create an object of RestTemplate first. So I'm going to say RestTemplate over here. You can see this RestTemplate coming in from org.springframework.web.client. So I'm going to take this. I'm going to say RestTemplate is equal to new RestTemplate over here. Okay, and I have this RestTemplate now. Now what I'm going to do is I'm going to say RestTemplate dot. You can see over here there are a lot of methods that you get access to. You can see get for entity, exchange, delete. You have a lot of objects, a lot of methods over here. You can see get for entity. Okay, you can say get for like you have a lot of patch, post. You can see post for entity. So this is for get request, post request, put request. You can see. So I'll make use of get for object over here. This is what I'm going to make use of. And you can see if you take a look at the parameters, the first parameter is the URL, and then you have the other parameter as the object basically. So you want the response mapped to which object? So I want the response mapped to string class. Okay, so I'll just add that, and here I'll add the URL. So I'm going to say over here, so I have the URL. Okay, so it's localhost 8081 instance info. So I have it in the browser. I'll come over here and I'll just paste this URL over here. Okay, so let me take this to new line, and now you can see this is what the method is. Okay, so this is how we are calling RestTemplate. You can see we are saying that call this particular URL, make a get request, and map the response to this object over here, string, and it will return a string over here. So what I'm going to do is I'm going to say string response over here, something like this, and I can return this response over here. You can see here like so. Of course, you're getting a warning. You can make this variable inline, but I'll just leave it like this. You can choose to do that. Okay. Now I'll start the provider application, and what I can even do is I can add the applications over here to services. So I'll say add a service. So run configuration type. I'll select application over here. You can see both these services appearing over here now. Now you can manage both the logs for both the services from here itself, right? You don't need to toggle. So now what I will do is I'll restart my consumer application, because I've made changes to my consumer application by adding a controller and also making use of RestTemplate, right? So the consumer application is started. Now what I will do is I will head over to the browser and I'll refresh the endpoint. Okay. But before refreshing, I'll do one thing. I'll just clear the logs of provider over here. So we don't have any logs for provider. Okay. Now let me call the consumer endpoint. This is a consumer one, 8080. So I'll just refresh this. And now you can see over here, instance served by this port. And this is the instance ID that we are getting, which is a unique identifier. And now if you come over here, in provider application, you will see over here at the bottom that request is received at instance running on port 8081. So the request hit this particular microservice or this particular service over here. And you have this consumer that gave you the response. So with this, we are able to successfully make a inter-service communication, and one service is now able to communicate to the other service. Okay. And now if you take a look at RestTemplate over here, so if you go to this class over here, okay, so you can see once I go to the class, it's telling me to download sources. So I'll say download over here so that I get some documentation as well with it. So you can see over here, this is the class. Now you can see the documentation. So here you can see Synchronous client to perform HTTP request, exposing a simple template method API over underlying HTTP client libraries such as JDK. You can see this is the entire thing. So RestTemplate is typically used as shared components, and there are a lot of things that mentioned over here. Okay. And okay, it also mentions that as of 6.1, as of Spring Framework 6.1, that is what it means. RestClient is the suggested way. That is what it's mentioning over here. Okay. But yeah, a lot of projects that you will see will make use of RestTemplate. Okay, but you know, this is one of the disclaimers over here, because REST template was there or added really in the beginning, and right now Spring recommends that you move to RestClient if you're building new projects. Okay, so you should migrate to RestClient. That is what they are recommending over here. Okay, but yeah, this is the entire class that we made use of. Okay, now what I will do is instead of hard coding REST template like this, okay, instead of doing things this way, we can define REST template. Okay, we can define it as a Spring Bean, and we can make use of it in our application. All right. So what I will do is I will create a new class called RestTemplate config, wherein I will expose a bean over here of REST template, and that bean will be used everywhere else in my application. So that is something that we can do over here. So I'll just migrate to a better code over here. So I'll comment this, but not now. Okay, let me come over here. First, here I will create a new Java class. Okay, and I'll call this Java class as RestTemplate config. You can just call it config, but since I don't want this config name to conflict with something else, some other configuration, so I'm creating it as REST template config, and I'll say over here this is a configuration class. I'm mapping this or marking this class as a configuration. Now over here I'm going to say public REST template over here, and I'm going to say REST template like this, and it is going to accept the object of type REST template builder over here. You can see this is the builder, and here you can say builder, and here you will say return builder dot build. Okay, so this is what we are doing over here. Now the benefit of having a bean created this way, okay, so I have not marked this as a bean over here first of all, so I need to mark this as a bean. Okay, now the benefit of creating bean this way is REST template instance is created once and reused across the entire application. So if you want to make use of REST template at 10 places, what you have to do is you have to create instance 10 times in 10 different classes or 20 different classes if your project is big, you know. So this way you don't have a single instance, you have new instance being created every time, which is not good. You have a bean over here and you're making use of Spring over here, right? Come on. So let's make use of Spring features like dependency injection and all, right? So we should leverage that, and this gives you better performance, efficiency. There is no redundant object creation, okay, and there is centralized configuration. So tomorrow if you need to add some sort of additional configurations to REST template, interceptors, timeouts, or any other sort of configuration changes you have to do, you have to just do it in this central class, which is giving this REST template bean to the entire project, right? And you don't have to look for all the instances of where REST template is being used and where you are instantiating it and all of that. So that is avoided, and it saves you from a lot of hassle. So that is why I'm choosing this approach. Okay. Now what I will do is I will create a REST template client as well over here. So I'll come over here. Okay. And I'll create a Java class, and I'll say REST template client, something like this. Okay. I'll say, and here what I will do is I'll mark this as a service, something like this. And here I'm going to say public string get instance info, something like this. Okay, so this is a method that I'm creating over here to abstract the details of doing the API call. Okay, so basically I'm doing that, and you'll have a clarity as I write the code. So I'll say private static final string, and I'll say provider URL, something like this. Okay, you can also add this in the application properties file and get it injected using the value annotation, but I'm just hard coding it over here by choice. Okay, so you can do that if you wish to optimize your code further, but I'll just copy this entire URL. I'll add it over here. I'll get rid of this latter part over here. Okay, 1 second. So I'll just get rid of this latter part over here. I'll just add a semicolon. Okay, and then I'll come over here. I'll say return REST template over here, which does not exist, of course. I'll say get for object over here, and here in place of URL I'll pass in this URL. So here I'll say provider, so here I'll say provider URL. I'll concatenate it with instance info. Okay, and here I'll say string dot class, something like this. Okay, So this is what I'm doing. Yes, we have some red marks, but let's have some patience. Okay, I'll just clear all of this. So here now, we need to get the object. So I'll say private final rest template over here. I'll say rest template, something like this. Now we need to auto wire this. So one way is you add a constructor parameter, something like this, so that the bean that you have created over here, Spring will inject that bean over here. Okay, but since we are making use of Lombok, you can make use of this approach, but since we're making use of Lombok, I'll just reduce this boilerplate code and I'll say over here required args constructor over here. So it will automatically generate the constructor for final fields over here, okay, which is this one over here. So this is done, okay, and then I come over here, we have rest template and we are calling get for object. Yes, this is done. Now we can make use of this method over here in the controller. So what I would do is I would simply comment this out, this entire piece of code. I'll come over here, okay, and I'll say return, and we can get the rest template client injected over here, right? So I'm going to say private final rest template client over here, something like this. I can say rest template client, and then I'll say rest template client dot get instance info. Okay, so you can see over here. Now I need to get this injected, so you can add a constructor parameter, okay, or you can add an annotation which is required args constructor from Lombok. Totally your choice, right? Now this is something that we have done, and let me restart the application over here so I can restart it from here. Consumer application is what I'll restart. So you will observe that, okay, so I get an error. This variable is not initialized in the default constructor. Okay, so let me see over here. So for this issue, I'll just check the Lombok related settings in my IDE. So I'll just go to IDE settings, build execution deployment, compiler. I'll select annotation processing, and I'll make sure that annotation profile for both the applications, consumer and provider, is set to obtain processors from project class path. I'll say apply. Okay. And let me try starting the service now. Let us see what happens. It should start now without any hassles. Okay, so it was a Lombok related issue. Okay, so you can see consumer application is started. I'll come over here. And now if you call 8080 again, if you refresh this, there won't be any issue. You can see I refreshed it twice, thrice. I don't remember, but here you can see like 3-4 calls happening. I can clear this out and I can show this entire thing to you as well. Okay, so I refreshed again and you can see request received in the provider. So it's working absolutely fine. Okay, another thing is if you don't want to create so many classes, like 3 classes over here. One is for REST template configuration. Another one is to define the endpoint and basically define this get instance info and just return the response from the REST template. So I've used this, and then I'm making use of controller over here just to make one call over here to the service. If you don't want to do so many classes, you can just skip this service class, okay, and move this code over here, the code that we have written over here, to the controller. That is also acceptable, but I have kept the code segregated over here. I have a configuration, I have the client, and then I have the controller. So tomorrow if my application grows, let's say this small application grows, then I have this client created for myself, and I can duplicate, or I can make use, I can have multiple methods over here for different API calls. Okay, so let's say over here we have the provider controller, right, in the other microservice. Okay, not provider application, but instance controller. So this is the endpoint that we have, which we are calling from the other microservice, which is the provider microservice. Okay, let's say this controller grows and there are 10 other APIs that are added now in future. Okay, get instance configuration, get instance name, and all of that, different kinds of APIs. So what I can do is I can improve or develop my REST template client over here to accommodate those multiple endpoints. So I can duplicate this method over here, and instead of get instance info, I can rename this to get instance name. And here I can modify the endpoint accordingly. Okay, so that particular method now will call, or it will call the get instance name endpoint from the provider. So all those things are possible, and it makes your code much more clean, scalable, and much more organized. So that is the benefit that I could see over here. Okay, so yeah, I hope this is pretty much clear to you all as to what is happening over here. We took a look at an example wherein we made use of REST template for making API calls. I showed you two ways. One is directly hard-coded approach, where we just hard-coded. We created the object of REST template like a normal class object, and we made use of it. And another way is where we make use of Spring-related features like dependency injection, wherein I created a centralized configuration class over here, and then I created a REST template client which maps to the URLs or the endpoints on provider, and then I made use of controller to call that, and the client was marked as service, as you can see over here. So I hope you have been able to follow along, and I hope this has been super useful. So now it's time that we are going to take a look at OpenFeign and see how we can make use of it in our project. So I have two services over here, consumer and provider. Provider is running on 8081 and consumer is running on 8080. And provider has this controller. It's a very simple controller, which is just returning the instance information over here. Okay, I've kept it really simple. And what we are going to do is we are going to have inside consumer, we are going to have a way using Feign, like OpenFeign. We'll make an API call to the provider and we'll consume the information and display it to the user. That is what we are going to do. The objective of this exercise is to see how you can put OpenFeign into action and how you can make use of it in your project. Okay. Now, to know more about OpenFeign, just come over here to spring.io. This is the official website of Spring. Under projects, you will see Spring Cloud, and under Spring Cloud, you will see over here somewhere OpenFeign. So OpenFeign is a part of Spring Cloud, and if you go inside, you'll see details of OpenFeign over here. So what is OpenFeign? OpenFeign is a declarative REST client. Okay, now it enables you to basically define an interface. Okay, and you can see over here, it creates a dynamic implementation of an interface decorated with these annotations. So Feign is considered to be a better approach than RestTemplate. Now Feign and RestTemplate both serve the same purpose of simplifying HTTP requests in a Spring application, but they do so in a slightly different ways. Okay, RestTemplate, if you take a look at it, is an older and more traditional way of making HTTP requests. It is robust, flexible solution, of course. It offers a lot of control, but it can lead to a lot more verbose code, especially when dealing with complex requests. On the other hand, OpenFeign or Feign is a more modern solution that takes a different approach. Instead of creating a template like you do in RestTemplate and you fill in the specifics, Feign creates a proxy based on an interface you define. And then this proxy, because of this proxy, it results in a very clean and simple code, but it may not offer the same level of control for complex scenarios as RestTemplate. Okay, so in the end, the choice comes down to your specific needs and preferences, but OpenFeign is much more better as compared to RestTemplate over here. Okay, now if you go over here, I would like to just highlight something. If you go over here actively, there are no new features. If you go over here and see, there are no new features that are being added to OpenFeign. And if you go over here to this blog article, in this Spring Cloud 2002 announcement, it's been clearly mentioned that Spring is now providing its own HTTP client solution. Okay, so they are going to treat OpenFeign as feature complete. Okay, so no new features will be added over here, but it's important that we learn this. Okay, because a lot of projects are making use of OpenFeign. Okay, so I'm not discouraging you to learn that, not to learn over here, but learning this is also important because a lot of projects are making use of OpenFeign, and we should have the knowledge of how OpenFeign works. Okay, but you should be aware of this information, and that is why I'm highlighting it over here. Okay, now to get started with OpenFeign over here, what we will have to do is so here. Okay, I don't have anything over here, but we need to add a dependency. So I'll quickly head over to Spring Initializer. I'll say add the dependency, and here I'll say OpenFeign over here. You can see this OpenFeign. And I'll select this. You can see this is a declarative REST client, and it creates a dynamic implementation of interface. Now I can say explore over here, and if you scroll down, okay, if you scroll down, what we need is we need OpenFeign over here. So this is what I'm going to copy actually over here. Okay, OpenFeign. I'll come over here to my project and I'll add this in my consumer project because the consumer is going to do an API call to the provider. Okay, so I'll scroll down over here, and here I'll add this dependency. Okay, now keep in mind it's a part of Spring Cloud project, and if you scroll down over here, so if you come over here, you can see here under dependency management, you will see that so after this dependency tag is closed over here, this dependency tag, you will see dependency management being added over here, and it has Spring Cloud over here added. Okay, so this also you need to copy. So I'll just copy this, and here just under dependencies between build and dependencies, I'll add this. Okay, and one more thing over here is Spring Cloud version. So this version between properties is what you need to copy, since it's a part of Spring Cloud project, because this version number is being used over here. You can see it's being used over here. So I'll scroll up, and here under properties, I'll paste this. Okay, if you're finding it complex to paste things like in bits and pieces this way, what I would recommend is whatever you have chosen when creating this project, okay, like what group ID you have chosen, what artifact ID, what name you have chosen, what description was there, and what dependencies you want now. So recreate, fill in all this information over here. Okay, so just say close, fill in all the information over here, and just recreate the pom.xml over here. Copy this entire pom.xml and just paste it so that you minimize the risk of any sort of errors, you know. So I'll just reload all the Maven changes because I've made changes to pom.xml. So I'll quickly click on this icon, or if you're not seeing this icon, you can of course click it from here as well, right? So all the dependencies have been added to our project now. So now what I would do is I would come over here, and here under the main package of our consumer over here, I'm going to create one more sub package because all the Feign related code will reside over here. Okay, and you can call this package whatever you want to. So I'll just keep it simple. I'll say Feign over here so that it's easier to identify that all the Feign related code or OpenFeign related code resides here. Now I'll add two classes over here. One is basically a controller. So I'll say Feign controller over here. This is one class. Okay, I'll leave it as it is. And then I need one more over here. I'll say new and Java class. So this won't be a class. In fact, it would be an interface. Okay, so I'll say Feign client over here. Okay, so we can define a client. Okay, so I'll do that over here. This is done. Okay, so you have a controller now and a client over here, right? I'm going to make use of the controller. So first thing, I'm going to define REST controller over here. This is done. And now I am going to have a method over here, which I'll link to the endpoint. So I'm going to say public string get instance, something like this. Okay. And then over here, we'll return something, but right now I'm not returning anything so that I'll avoid the errors. And now I'll say request mapping over here, and I'll map this entire file to basically /API/Feign, something like this. Okay. Now I'll scroll down, and yeah, we need to add client over here, and we need to make use of client to make the request. But before doing that, what I will do is I'll come over here. So here now what I'm going to do is I'm going to add this annotation Feign client over here, and I'm going to add a few parameters like name. Okay, a couple of them. This is name, and then I have the URL as well. Okay, so these two parameters is what I'm going to add. Okay, now what is the name over here? So I'm going to call this as provider service. Okay, and what is the URL over here? So the URL is HTTP localhost, and it's the URL of provider over here, something like this. Okay, and one more thing, we need to also come over here to the main application class, and we need to add an annotation over here at the top. I'll say enable Feign clients. Okay, this is done. Okay, so let me also define the endpoint over here. So I'm going to say get instance detail over here, something like this, like so. I can call this as, instead of instant details, I can call this as info over here. Okay, I'll add a semicolon, and I'll get this to return string over here. Okay, now this is not being identified over here. I need to get this imported, okay, from here, but it's getting imported this way. I'll tell you the problem over here. This is Feign client, and this class name is also Feign client. So there is a conflict over here. So I'll just rename this class, or sorry, not class. This is the interface. So it's considering this as interface. So I'll just right click, refactor, like rename, and instead of Feign client, I'll rename this to I can call this as provider Feign client. So the name does not matter over here, but I'll call this as provider Feign client. And now this will be Feign client over here, something like this. So you can see this being imported now, okay, Feign client. And now you have this method inside, which is get instance info. All right, this is done. Now what we need to do is here, I'll add get mapping over here because this is a get mapping, get request, right? So I'll map this to the instance info endpoint. So I'll say instance hyphen info endpoint. And this is the endpoint that is working absolutely fine over here. You can see localhost 8081/instance info. And it is returning the instance info of the instance, right? So I'm calling this over here, right? Now this is done. And I think this is it for Feign client. So what we did is we created this interface called provider Feign client. Don't name it Feign client, please. Otherwise you will land into import issues like this. There will be a conflict with this, right? So have provider Feign client, or if you are creating a Feign client for product service, have it product service Feign client, something like that, or product Feign client, something like that. So prepend the service name is what I'm telling you. Okay, this is done. Now also one thing we did is we added the annotation over here. This was important. Enable Feign clients over here in the main application. Okay, now this is done. Like this was the setup part. Now let us make use of controller over here. Okay, now what I will do is here in the controller, I will add over here, I'll say private. Okay, private final. Okay, final, and I'll say provider Feign client, and I'll say provider Feign client. Okay, and of course it is telling us to like add a constructor parameter, but I'm making use of Lombok over here. So I'll say required args constructor, something like this. So this will be auto injected now. And now here I'm going to see this is get mapping over here, and I'll say this has to be something like /instance, something like this. Okay, and here I am going to return, I'm going to say provider Feign client dot get instance info. That is it. So this is done. What we are doing is we have done a interface definition and we have marked it as a Feign client, and we have mapped this to the URL, and we are making use of a get mapping over here to map this to this particular endpoint over here within this service, okay, which is the provider service over here, and it should be taken care of, right? And here we are making use of the method inside interface, right? Now let us restart our provider application. Okay, so I'll head over to API/Feign over here. Okay, so first thing I'll come over here, then here I'll start a new tab and I'll say localhost 8080 API/Feign/instance, like so, and I'll press enter. Okay, we get an error. So what is the error over here? Okay, so instance, let me see over here. Okay, so it worked. It seems I did not restart the application after making changes. So after defining this new controller, just restart consumer application. That is important, you know, otherwise how will your changes come over to the server, right? So I just missed restarting this. So I restarted this and I come over here and I did a refresh and it was working fine. So I did a couple of refreshes, and here in provider application, you can see a couple of prints over here, right? So clearly we are able to make an API call with the help of OpenFeign. What do you think about this approach? Okay, this is a better approach, and yes, it's still being used in a lot of projects. Okay, but you should be aware of how you can make use of OpenFeign as well. I am 100% in with this as well. Okay, you should have this knowledge as to how you can create Feign clients and how is it better with other from other method like RestTemplate. Okay, so you can see over here there is ease of use. It has other features like there is integration with Eureka server if you set that up. Okay, so all those benefits are there, of course, but the major benefit is like a lot of reduction in the boilerplate code. Now tomorrow, here if I come to this controller here, which controller? This controller, the controller in the other service which we are calling in. So if I come over here, let's say if this application grows, the small application, and there are like multiple endpoints like instance info, get instance name, get instance configuration, all of that. There are 10-20 endpoints now in the single controller. So you can come over here to provider Feign client and you can just add those many number of definitions over here. You can just replicate this. So instead of get instance info, you can duplicate this and add get instance name, and you can add the relevant endpoint over here. So all of that can be done, okay, and it's all for the same service. So this client is now linked to this particular service over here, right? So I hope this has been useful so far, and I hope you have been able to follow along. If you're enjoying this course so far, then you should also check out our complete full stack development mastery roadmap, the details of which are given in the description below. It comprises of multiple courses that you would have access to. Also, you'll find these details on the website as well. All right. The website is embarkx.com, and I would highly encourage you all to check this out to become a pro developer. So now it's time that we talk about RestClient with Spring Boot, and we'll understand how we can make use of RestClient to do inter-service communication in our Spring Boot services. Okay. Now RestClient is just another way. It's a Spring HTTP client over here. As you can see over here, I'm here in the official documentation of REST clients, and you can see over here RestClient is listed as one of the ways. So it's a synchronous client with fluent APIs is what it says. So if you scroll down over here, or if you click on this link over here, you'll be taken to this thing, and here you can read more about RestClient. So you can see over here, this is how you make use of RestClient to do an API call. All right, so this is what we are going to make use of. So I'm going to come over here to our application. We have two services up and running. One is the consumer, another one is the provider. Provider is running on 8081. Okay, over here, this is what the port is, and the consumer is running on 8080 over here. Okay, and provider, so you can see over here 8080, and provider has a controller, which is the instance controller, which is simply returning the instance related information. All right, and we need to consume this using RestClient over here via the consumer. So I'll just collapse provider over here. I'll come to consumer, and here under Java, the main package, I'm going to say right click. I'll select package over here, and I'm going to say RestClient over here, something like this. Okay, and under this package, we will create everything. So first thing we'll need over here is a controller over here. Okay, so I'm going to say RestClient controller, something like this. Okay, because we are demonstrating and understanding how we can make use of RestClient. Okay, so here what I'm going to do is I'm going to first define the way, or first define the endpoint over here. That is what we are going to need first. So I'm going to say REST controller over here. I'm going to add a request mapping over here, and request mapping will help us map this entire controller to a request or to an endpoint. I'm going to say /API/REST-client over here. Okay, this is done. Now over here, I'm going to say get mapping, something like this. And here I'm going to say public string, and I'm going to say get instance over here, like so. Okay, get instance, and I'm going to add some information over here. Okay, now this endpoint will be linked to /instance endpoint over here. Okay, now here let us make use of RestClient. Okay, now how do you make use of RestClient? You can see some example over here. Okay, so what I'm going to do is I'm going to come over here. Okay, and I'm going to say RestClient. You can see RestClient up here. Org Spring Framework web.client. So I'll get this. I'll say RestClient over here is equal to RestClient, and you can see over here RestClient.create. So I'll say RestClient.create over here, something like this. Okay, so this is what we will make use of, and now I will configure this RestClient to query the localhost 8081 endpoint and get the response. Okay, now how are we going to do that? So here I already have the endpoint triggered for 8081. You can see this is the endpoint. So I'll copy this over here. Okay, I'll come over here and I'll make use of this object RestClient. I'll say RestClient dot. Now you can see over here there are so many methods like delete, get, head, method, put, mutate, options, patch, post. You can do all these kind of requests. You can do delete, get, put, and post. This is what normally is used, right? So I'll select get because it's a get request is what we are willing to do. Okay. And here I'm going to say .uri, something like this over here. Okay. And I will specify, okay, 1 second. So I'll add the URI over here. Okay. And then over here, I'll say .retrieve, and then I'll say over here body, and I'll get this to string .class, something like this. Okay. So this is done. So what we are doing is we are calling this endpoint over here. Okay. We are retrieving the input. We are retrieving the information, and then we are converting the information into string. And I'll accept this as a string over here, string response. Okay. Something like this. Okay. And then we need to return the response over here. Okay. So I'll say return and response like so. Okay. This is done. And then let me restart my consumer. Okay. So I'll restart my consumer and let us wait until it starts. I'll just clear the logs for provider so that we can see some sort of fresh logs. And now I'll come over here and let me create a new tab. Now over here, I'm going to say localhost :8080. Okay. And I'll scroll up. This is the endpoint over here. Okay. I'll come over here and I'll paste this /instance, something like this. So I'll hit this, and now you can see the request is served by port 8081. So this is coming in from 8081, and this is the instance ID. Okay. Now if you come here, okay, you'll see in the provider application, you can see request is received. We cleared the logs, right? So you can clearly see the request is triggered to the other service, which is running independently on a different port. Okay. So yeah, this is how you can make use of, RestClient over here in your application. All right. Now, what we can do is, this is one way of doing things wherein you have created an object of RestClient and you are using it to make an API call. Okay. Now, what I can do over here is, instead of creating an object of RestClient over here, I can convert this into a bean. Okay. And I can mark it as a configuration. So this bean is available across the Spring Boot application, and I can add any sort of custom configurations then later on. So for example, if I have to add any sort of custom headers or anything like that, I have to add them over here, right, to this object. But then this will be limited to this method and not elsewhere in the application. But with bean, you can make use of Spring related features like or injection, dependency injection, and all of that. Okay. And once you have configured a REST client with any sort of custom parameters, custom headers, any sort of custom configuration, okay, you can make use of it throughout your application. All right. So what we can do over here is we'll come over here and I'll create two more classes. So one is the config class. Okay. So I'll say REST client config like so. Okay. And I'll create one more over here. I'll create a Java class and I'll say REST client over here. So I'll say provider REST client, something like this. Okay. So I'll tell you what this provider REST client is, but for now, let us focus on this configuration class, which we just spoke about, wherein we will have a bean created on the fly. Okay. So I'll first mark this class as a configuration. Come over here. Okay. And here I will create a bean. And here I'll say public REST client over here, and I'll say REST client, something like this. And here I'll say REST client dot builder. Okay, and I'll say builder over here. And here, what you can do is you can return over here. So I'll say builder dot base URL. So I'll add the base URL first over here. Okay, whatever the base URL is, and then you can say dot build like so. Okay. So that is something that we'll be doing. And here you can configure the base URL. So what is the base URL? This is the base URL, not the entire one, but just the base URL of the server. So I'll get this and I'll get it added over here. Okay. So this is a base URL. And so what we are doing over here is we are creating a configuration over here we're creating a REST client. And this REST client is basically available as a bean to the entire application, and it is configured with this base URL. Okay, this is for this particular server. instead of calling this as RestClient config, if you have many clients that you want to configure, so you can have this as provider client config, something like that, because provider is the other service name, right? So it will be easier to identify. But right now I have only one client, so I'm not naming it that way, but this is one tip for you. Okay. Now, when I said like why this approach is better, the bean approach. So I explained that you can add any sort of custom configurations that can be available across the entire application. Now, what sort of custom configurations you can add? So you can add things like, if you do a dot over here, you can see default headers, cookies, message converters. You can add so many things, any sort of headers you want to add, any sort of cookie information with every request you want to add. You can configure that here. And understand this, if you did this configuration over here with this client object, RestClient object, this will be only available in this method and not outside that. Even if you declare this at the global level over here in the class, it is just available in the class. But you're making use of Spring, guys, come on. So why not like make use of things like beans and all, let Spring manage it, right? So here we can do any sort of custom configuration we need down the line. And suppose your project grows, this is a better approach. So I'm showing you all the ways of doing things so that you can, go forward with the right way for your project. Okay, so this is done. Now, what is the use of this RestClient over here? Okay, so the use of this RestClient is basically it will define all the methods that will map to the different endpoints. So here you have instance info, right, for provider. So you will create one method over here called get instance info. Okay, so that is something you will do. Let me show this to you. So first I'll mark this class as a bean over here, like so. Sorry, not a bean, sorry. I'll mark this as a service and I'll get rid of this import that was added. Okay, now over here, what I will do is I'll need an instance of private final. I'll need an instance of RestClient over here, right? So I'll say, so here I'll say RestClient and RestClient over here, something like this. And this has to be auto injected, right? So I'll add this annotation required args constructor. Okay, this is done. And now over here, what I'm going to do is I'm going to define a method. Okay, so let us have a method over here. Okay, public string, and I'll say get instance info over here, like so. Oops. And here, then what we are going to do is I'm going to say return, like so, and I will be saying RestClient dot get over here dot URI. And what is the URI? / instance hyphen info. And then you say retrieve dot body to string dot class, something like this. Okay, so this is what this method will have. Now if let's say we have this only one endpoint over here called instance info in provider, if this grows to 10 endpoints, then you can have 10 methods over here. So this is like a client that will help you interact with the provider service. That is what it is. Okay, so this class is helping you create an instance of RestClient, a custom instance. You can configure it the way you want, and it's making it available as a bean across your project. This is a way or a client using which you can talk to the provider, which is the provider service. And then you have the controller. So what you will do in the controller is, I'll just comment this now because we don't need this. Here in the controller, we'll first take the instance over here. So I'll say private provider RestClient over here. Okay, and I'll say RestClient, or you can call this as provider RestClient, something like this. And I'll get this. Okay, so this has to be private final, and I'll get this auto injected over here. Okay, because it is marked as service anyways. So required args constructor. Okay, now over here, what I'm going to do is I'm going to say return. So you can see provider RestClient dot get instance info. So that's a single line of code in your controller. That is it. Controller is lightweight. You have a separate class that will help you communicate with provider microservice, and then you have a RestClient configuration, which is helping you configure a bean, okay, and use it across your application. Now come over to services, and here let's restart consumer application, and let us see if it's functioning normally the way it would. Okay, so the application has started successfully, right? You can see, And here in provider application, I have one request over here. Okay, so if I come over here and if I refresh this endpoint 8080, the same endpoint, let me refresh. You can see, I can see the response, the instance ID changed. If you come over here, you can see the request was received in provider and you don't see any sort of errors in consumer. So this is working absolutely fine. All right. And I hope you people now have a good clarity of how you can make use of RestClient and how you can add it into your application. Okay. So I hope this has been useful so far and I hope you all found it valuable. So now in our application, we need to make use of WebClient basically to do inter-service communication. I have two services up and running for the same, one running on port 8080, which is the consumer, and I have provider running on 8081. Just as a reminder, provider is having this controller over here, which is just returning the instance info, and consumer will be making use of WebClient to basically consume this information. So with this, we'll be learning inter-service communication in a synchronous way, right? Now, let us talk about WebClient. So if you come over here to the browser, I have this article open from the official Spring documentation, and it lists the official REST clients for Spring. And you can see over here, WebClient is mentioned over here, and you can see it's a non-blocking reactive client with Fluent API. And if you click on this, you can see, you can read more about WebClient, and you can also go to this article over here and read more about it. Okay. Now, WebClient is a part of WebFlux, Spring WebFlux. So I'll have to add this dependency in order to make use of it in my project. So I'll come over here to Spring Initializer and I'll add the dependency and I'll say WebFlux over here. You can see this WebFlux and Netty Spring Reactive Web. So I'll select this. I'll head over to Explore and I'll scroll down over here and I can see this dependency being added over here. So this is the dependency, Spring Boot Starter WebFlux. Okay. I don't think anything else has changed in pom.xml. So I'll just copy this dependency. I'll come over here to my application and consumer is the service that will be making the API call. So I'll come over here and I'll just paste it under dependencies. Now, since I've made a change to the pom.xml, as a ritual, I'll just load all the Maven related changes so that the dependencies are synchronized. Now, once the dependencies are synchronized and loaded, I'll just close this pom.xml. I'll come over here to consumer, and here in consumer under the main package, I'll create one more package and I'll call this package as WebClient over here, which is the package wherein we will be demonstrating the usage of WebClient. Now over here, I'll create a controller. Okay, so I'll say a WebClient controller like so over here. And here I'll mark this as REST controller, something like this. Okay, and we will have an endpoint definition over here, which will do the job of basically exposing a method. Okay, and what we will do is, so it will basically expose a REST API is what I mean to say. And we can consume this REST API from the browser. And this REST API will do the job of calling provider endpoint. So let me show it to you. Okay, so I'll first say get mapping over here. And I'll say /instance like so. So this has to be /. And then I'll define a method over here. So I'll say public. And here I'll have the definition type as mono over here. Okay. And then over here, I'm going to say get instance like so. And I'll have to return the instance information. So we'll have some code written over here, but for now, I'll just return an empty string so that it stops throwing error. Okay. Okay. It's still throwing error, but that's okay. We'll ignore it for now. Okay. So here now I'll just say request mapping, and here I'll just map it over here. I'll say /API /web-client over here, something like this. Okay. And this entire controller is mapped to this particular endpoint over here. Okay. Now this is done. Now what I need to do is I need to start making use of WebClient over here. Now one thing that I would like to address over here is this mono over here. Okay. So when using Spring WebClient, mono represents a reactive type that handles asynchronous non-blocking operations. Okay. And it's a part of Project Reactor, which powers Spring Web Flux, and that is a dependency that we have added. So if you see over here, it is coming in from React over here. Okay. So here, what I'm going to do is I'm going to define the web client. So first I'm going to come over here. Okay. And here I'm going to say web client. You can see it's coming in from org Spring Framework Web Reactive over here. I'll create an instance for the same, and I'll say web client dot create over here, something like this. Okay. And then what I'm going to do is here, I'm going to say web client dot get, and then I'm going to say dot URI. Now we'll have to add the URI over here, and then I'll say retrieve, and then over here body to mono. Okay. And then over here dot block over here. Okay. Now body to mono, we'll have to add string dot class because we want the response as string over here. And then over here, we'll mention the URI. So if you come over here, I have this API call done over here in the browser. So this is a URL for localhost 8081. So this is what we need to call. So I'll call this over here. I'll add this URI, and then I'll add a semicolon, and we'll get this entire response over here as a string like so. So I'll say string, and I'll say response, something like this. Okay. This is done, and I'll return this. Okay. So we can return this response over here. So it is throwing an error. So what I will do is I'll get rid of this block over here, because body to mono is giving mono of string. So I'll just get rid of this over here. And now here I will have this variable added. Okay. So I'll say over here mono of string, something like this. Okay. So the error goes away, and then I return the response. Okay. So this is done. Now what we can do is let us test this. So I'll restart the consumer application. Let us test if this is working absolutely okay. Right. And you can see the application starting fine. There are no issues as such over here. Okay. So you can see it started the application. Now what I will do is, before making an API call, I'll clear this provider application console and the consumer application console. Okay. And then I'll copy this endpoint over here. Okay. Which is from the request mapping. Now let us head over to browser and open a new tab. So here now I'm going to say localhost 8080, and then I'll add this /instance over here. Right. So this is the API call that we need to make. Now if I say enter, you'll see the instance is served by port. This is the port number. The call has been made to 8080, but it's served by 8081. Okay. And you get the instance ID, which is unique. Right. Now if you come over here, if you go to services, and if you go to provider, you'll see that there is one request received over here. Okay. If you do a refresh over here, you'll see one more log over here. So request is clearly hitting provider application without any issues. We are getting the response successfully. And here in consumer application, you are seeing no issues as such. Okay. So this usage of web client is making sense, and it is working perfectly fine. Okay. Now this is one way of doing things wherein you can have web client instantiated over here, and you can do a call like this, and you can return the response. Okay. But if your project grows, it's best to have web client exposed as a bean in your application, and any sort of custom configurations that you make to web client that is available centrally to the entire application. For example, if you add any sort of custom config headers or something like that, whatever you add, it is available centrally, because now if you make any sort of custom configuration, it will only be available to this method. And if you make it global, it will be available to this class max, right? But we are making use of Spring, right? Underlying framework is Spring. So why not make use of things like dependency injection and all, right? So what I will do is I will come over here. I'll create 3 classes. So first class is the controller, which already exists. Second class will be over here. So I'll say web client config, something like this. Okay. This is the configuration class, which will define and create the instance for web client, right? And then I'll add one more class over here, which is the provider web client. Okay. So I'll say provider web client. Okay. So this is an interface that will help us interact with the provider service using web client. So I'll leave this as is for now. Okay. First we'll go to the web client config. Now in web client config, I'll do some configuration over here. Okay. So I'll come over here. First thing is, so this is a configuration class. I'll mark this as configuration. Then come over here. I'll mark this as bean over here. Okay, and I'll say public web client over here, and I'll say web client like so. Okay, and then I'll say return web client dot builder. So you can select builder over here, and instead of like returning the builder this way, what you can even do is you can take this and add it as a method parameter over here. So you can do something like this over here. Okay, and you can say builder over here like so. Okay, and you can return builder dot, and you can add the base URL over here. Okay, whatever is the base URL. Now what is the base URL? So if you come to controller, this is a base URL. Base URL is only the host URL. Okay, so you take this, you come over here, you add that over here. Okay, something like this. Okay, and then over here you can say the next line dot build like so. Okay, so this is now being exposed. Okay, this web client object over here, and it is being exposed as a bean. And now any sort of custom configuration you add over here tomorrow, you can like add default cookie, default header, default request, any sort of custom configuration or filter. There are so many things you can do. Okay, so it is centralized and it is shared across the application. So let's say tomorrow provider, like this provider over here, the service which we are calling, it wants a cookie to be sent. So what you have to do is, if you're making use of this approach over here, wherein you are instantiating web client in every controller, you have to add cookie information in all the places. And if you have 10 controllers, you'll have to add at 10 places, right? Or 20 places. But here you have a centralized config. You add it at one place over here, and it's reflected everywhere because everyone is now making use of bean. So that's the benefit. Okay. Now come over here to provide a web client. And like I said, web client is basically, this is an interface basically to communicate with that of the provider service, right? So I'm going to add over here all the method definitions over here that we are going to have over here for this particular provider service. So first of all, what are we going to need? We are going to need private final web client over here. Okay, web client like so. Okay, and I'll mark this as service over here, and I'll also have required args constructor over here, something like this. Okay, so this is added. Now over here, I'm going to say public mono and that of string over here. Okay, this needs to be imported. So I'll get this imported, and then I'll say over here, get instance info like so. Okay, and then over here, I'm going to say return web client dot get over here. You can see so many ways of doing an API request, like delete, get. You can do post, put as well. Okay, so this is a get request. So I'll say get over here. Okay, and this instance is pre-configured with the host URL, right? So I just need to now append the URI. I need to say URI over here. What is the URI? It is /instance-info over here. So that is what I'm adding. I'm going to say dot retrieve over here. Okay, and then I'm going to say body to mono over here. Okay, and I'm going to say string dot class, something like this. Okay, and I'll add a semicolon. So this is done. Okay, this is taken care of. And now what you can do is you can come over here to controller. I'll just comment this stuff out. Okay, so controller becomes very lightweight now. So I'll say private over here. We just need the client over here. So we need provider web. Okay, provider web client over here. So it has to be private final provider web client, and you have to say provider web client over here. And then you'll add all args not all args. You'll add required args constructor over here. And then over here you come and you can simply say return required, not required args constructor. It will be provider web client. Okay, dot get instance info. That is what you're going to do, like so. Okay, so controller is just calling this get instance info, which is the provider web client over here. Provider web client has this get instance info defined, which is making a call to /instance info and returning the response. And this is making use of web client over here, which is being configured using this configuration class. So that is how the chain of operations work. Okay. tomorrow, if your provider service grows and it has 10 endpoints, so you will update this web client with those 10 methods. So for example, provider adds a method or an endpoint called get instance name, then it adds get instance configuration. So you can add those many number of methods, you can duplicate this and you have everything sorted. Okay, so this is like an interface or a way for you to talk to provider service. This is done. Now here I'll just restart consumer because all the changes have been implemented over here. Okay, and we'll wait for a while until the consumer starts. I'll just clear out provider over here. Okay, consumer has started, you can see. I'll just clear this as well. Let's come over here and let me do a refresh on the same endpoint. So it works fine. If you come here, you can see logs over here and no errors. On provider also, you can see one request is received. So the request is being served by 8081, like the instance running on 8081, and the 8081 instance is the provider service, and it's successfully working basically. So we have been able to configure web client into our project, and we are able to see REST communication, like communication using the HTTP protocol with the help of web client. So I hope this has been useful. So now is the time that we talk about HTTP interface and how we can make use of HTTP interface to do inter-service communication. So for the purpose of the same, I have two services up and running, consumer provider running on 8080 and 8081 respectively, and provider is exposing a endpoint over here, a very simple endpoint which is providing the instance information. Pretty simple, a very simple GET request. Okay, now consumer is supposed to make use of HTTP interface to do the call over here. Okay, now consumer is supposed to do the request over here to the provider with the help of HTTP interfaces. So what I'm going to do is I'm going to head over to our browser first, and we'll take a look at this official article of REST clients provided to us by Spring. And you can see this article on docs.spring.io over here. It's about the REST clients that Spring framework provides. And one of the client over here, one of the option over here is HTTP interface along with RestClient, WebClient and RestTemplate. Okay. Now HTTP interface is a annotated interface with generated dynamic proxy implementation. What does this mean? Let us understand this in a bit depth. I'll click on HTTP interface over here. Now here you can read more about HTTP interface. It lets you define an HTTP service as Java interface with HTTP exchange methods. So you can see this here. We're making use of HTTP exchange methods and we are defining a service over here, which is an interface. Okay. And this creates a proxy basically to perform requests through an HTTP client. Okay. So this interface is creating a proxy to perform request through HTTP client. Now, what HTTP client are we talking about? We are talking about two HTTP clients, which is RestClient or WebClient. Okay. So you can see over here, if you scroll down over here, okay, there's one more point. You can also implement the interface from an controller for server request handling. Okay. So this is how you create the interface. You scroll down and you can see here, you'll see two implementations for RestClient and WebClient over here. Okay. So this same HTTP interface, so this product, sorry, not product, it's a repository service. So this repository service is being used here. Okay, you can see repository service and it's being used here as well. Okay, and the clients differ, WebClient and RestClient. All right. So what I will do is I will head over to the IntelliJ and we'll start defining this. So I'll switch over. So now over here, I'm going to come over to consumer, and here in the consumer, we are going to need three files over here. One is a controller. Then we are going to need the proxy, okay, which is the interface, which will be product HTTP, sorry, not product, which will be an HTTP interface. And I'll call this as provider HTTP interface or something like that. And then we will have the configuration for the clients. Okay, so let us understand this clearly. So I'll come over here. First, I'll create a package. Okay. And here I'll call this package as HTTP interface, something like that. Okay. Now here I'll create three files. Okay. So understand this. This one is HTTP interface controller over here, something like this. Then we have one more file over here, which is a Java class, and this will be an interface, and this will be provider HTTP interface. Okay, it's an interface created, and then we will have a client over here, which is also a Java class. So it will be HTTP interface config, like so. Okay, so this is what we will be doing, and what I will do is first I'll come over to HTTP interface over here. Okay, so here we'll start defining things, and what I will do is here I'll define this, or I'll mark this as HTTP exchange. You can see this HTTP exchange annotation. This is what I'll add, and then I'll say string get instance info. Okay, so this is the method that I'm defining over here. Okay, and I'll map this as get exchange over here, and I'll add the endpoint over here. So I'll say /instance info, like so. Okay, so this is what we have done. We have this interface created using HTTP exchange annotation, and I have a method which is mapped to instance info. Now the question is, where is the host URL? We have not defined that. Okay, so we will be defining that when configuring the client. So let me show that to you. So here I'll come over to HTTP interface config. Okay, now here, so the crux of HTTP interface lies in allowing you to make use of different clients such as RestClient and WebClient. So you can make this HTTP interface and use it with RestClient or WebClient, like any underlying client, right? So I'll come over here. Okay, and here I will first mark this as configuration. Okay, and here what I'm going to do is I'm going to say public. Okay, now this will return the type of interface. So I have to say provider HTTP interface over here, and you can call this as so the method name can be, so if you come over here, you have example, right? Okay, so the example is just of the code over here. Okay, there's no method name, so I can call this as so let us have this implementation for web client. Okay, so I'll say web client HTTP interface, something like that. Okay, like so. Okay, and here we will do all the magic. Okay, so we are making use of web client, so I'll copy this over here. Okay, so this part I'll copy. Okay, and I'll paste it over here, like so. Okay, now over here, if you see, let me take this to the new line, webclient.builder.base URL. So I'll just import web client over here because we are making use of web client. Web client adapter, I'll import this as well. Okay, and HTTP service proxy factory, I'll import this as well. And then this is repository service. So this won't be repository service, but this will be HTTP, like provider HTTP interface. Okay, that is what it will be. Okay, so that is what I'm doing over here. Okay, so this is done, and now here we have to define the host over here. So I'm going to say localhost :8081, something like this. Okay, so this is done and it's defined, right? So this is the same code that we used, and we have to return it over here. So what I will do is I'll mark this as a bean. Okay, and I'll simply return service over here. So I'll just go over here, I'll say return service, like so. Okay, so this is done, and we have created this bean of where provider HTTP interface. Now what I would do is I would come over here to controller. I'll mark this as REST controller, and I'll say request mapping over here. Okay, I'll map this to API. Okay, so I'll add /API/ I'll say HTTP-interface over here. Okay, and here I'll add get mapping. Okay, and I'll say public, and here we can add string over here, and I'll say get instance details, like so. Okay, so this is just a simple endpoint that I'm defining over here, and I'll have this endpoint defined as instance over here, like so. Okay, and I'll say return over here, and to do a call I'll need the instance of provider HTTP interface over here, right? So what I'm going to do is I'm going to say private final provider HTTP interface, and I'll say I'll call this as client over here. Okay, and yes, this has to be initialized. So what I would do is I would come over here and I would add required args constructor, something like this. Okay, now over here I'm going to say client dot get instance info. Okay, so I hope this is making sense now. So all right, so this is done. So you can see I'm making use of, I'm calling client dot get instance info, and I'm making use of provider HTTP interface. What is this interface? This is this interface which is having this method defined, and it is mapped to this endpoint. And how is this configured? So here you have HTTP interface config, okay, which is being marked as configuration class over here. Okay, and this is also defining a bean of provider HTTP interface. And you can see over here, it is returning this bean with the configuration of WebClient that is pointing to localhost 8081. Okay, so if I now start this application, so let me start consumer application. So consumer application is starting, and I will clear all the logs of provider application. Okay, consumer application is starting. Let's wait for a while until this completes. So you can see it started. I'll just clear all the logs. Come over here, open a new tab. Now here you can type in local host colon 8080 / API / HTTP hyphen interface / instance, like so, and just press enter. Okay, we are getting an error. So what is the error over here? So error is related to an SSL over here. You can see SSL error. So the problem is this HTTPS should be removed. So I just copy pasted the code that had HTTPS. So this should be HTTP, right? Because we are not making use of SSL over here. So I'll just restart consumer now and let us see what happens. Okay, I got the error in provider also, so I'll clear that. Okay, and now let's wait for the consumer to start. It should start properly. Now it started. I'll clear the logs. Come over here. Let's do a quick refresh. You can see it's working fine, right? And now if you come over here and go to provider, you can see like we have a request appear over here, right? Now what we are doing over here, we have made use of a declarative way basically to make API calls. Okay, so this HTTP interface is added in Spring 6. It adds the ability to create declarative HTTP interface, right? And it facilitates using existing HTTP clients like RestTemplate, WebClient, and even RestClient. Okay, and this is similar to OpenFeign. Like if you have seen Feign, it is similar to that, but it's recommended that if you're starting new projects and if you want to, if you're making use of latest things, okay, then it's preferred that you use this for new projects. Okay, and what it does is it creates a proxy over here, HTTP interface over here. So it creates a proxy over here, and it performs a request. And then what happens is when you're making requests using this HTTP interface over here, you can see we're making requests using this HTTP interface in the controller. So during runtime, it is attaching this, okay, the instance of this to the HTTP client it's configured for. So it's configured for this client over here, and it is being exposed as bean. So this is automatically configured over here. Okay, and then the client is the call is happening using WebClient because that is what you have configured. Okay, now let me show you one more example over here. Let me modify this code a bit. So here we saw like we made use of WebClient. We can even make use of RestClient over here. What I will do is I'll come over here. I'll just duplicate this. I'll just copy this, comment this, paste it over here. Okay, and instead of WebClient, I'll just say RestClient over here, RestClient, and I'll keep URL and all same. Okay, or let me modify this code over here. So I'll just take this code from here. Okay, from the official documentation, I'll paste it over here. Okay, like so. Okay, just paste it, and I'll just import this RestClient. I'll import RestClient adapter. We have, instead of repository service, this will be provider HTTP interface, and this also will be same. Okay, so I'll add this, and this URL will be updated. Okay, so I'll just press enter over here like so, and I'll just copy this. Okay, and I'll add this like so over here. Okay. So this is now making use of RestClient, and let me restart the application now. Okay. So I'll restart the application. Let us see if it works using RestClient. Okay. So let me start the service. You can see the service has started. So I'll just clear provider application over here, and the consumer application is started. I'll just clear the logs, come over here, and I'll just do a refresh over here. So you can see it's working fine. And if you come over here, no issues as such, and here also the request is working fine. Okay. Let us do one more round, and we will configure this time with RestTemplate. So if you see over here, we have an example as well with RestTemplate. You can see this is the example. So come over here. I'll just duplicate this code over here. Okay, I'll just copy this and I'll paste this over here. Okay, and I'll comment this out like so. And instead of RestClient, this will be RestTemplate like so. Okay, and here what I'm going to do is I'm going to add this code, okay, which is making use of RestTemplate over here. So I'll add this like so. Okay, and I'll return service. Okay, and then this will be of type HTTP, like provider HTTP like so, provider HTTP interface like so, and here I'll have provider HTTP interface. I'll just import everything, like all the missing classes. That's all we need to do. And yes, I think, okay, we need to add the URL over here. So I'll just copy this and I'll paste it over here like so. Okay, so you can see this is a configuration for the RestTemplate over here, right? So let me restart this now. Now it should work with RestTemplate. We don't have any other clients configured. So I'm restarting consumer application, and while it restarts, I'll just clear the logs of provider application. So this is clear. Now for consumer, we'll wait, and it's started successfully. Let me clear the logs over here as well. So that we see fresh set of logs. And here I'm going to do refresh. Come over here, you'll see no issues as such. And for provider application, you'll see there is one request received, right? So this is working absolutely fine. And here we are making use of this declarative thing, okay, which OpenFeign or Feign used to provide to us. And with HTTP exchange or HTTP interface, this is possible with the help of just annotation. So it's a declarative HTTP interface that we are making use of, similar to Feign, right? And I hope you have been able to follow along, and I hope it has been useful so far. And you can imagine the best part over here is, if you can see, this is simplifying the code and it is improving the readability. So you just have this provider HTTP interface over here. Now tomorrow, if the provider service grows, the service where you are making the call, it grows. And let's say in the controller, you have now 10 methods. So you will add those 10 methods over here. You will duplicate them, right? And over here in the config, you don't need to do that. You don't need to do any sort of changes in the config, right? You just need to like update the interface over here with the new instances, and you need to map them to the method names. And then you need to start making use of those method names. That is it. That's the only thing you need to do, right? So I hope this has been useful, and I hope you have been able to follow along. So there will be a question in your mind, which REST client should I pick for my project, or which one is right, or how should I make the decision? So in this video, we are going to talk about few parameters that can help you make this decision. So we are going to take a look at few parameters and understand how we can choose the right REST client for us. So the first parameter is legacy versus new project. Now, if you're maintaining an existing code base, okay, you will see things like RestTemplate, and you will see things like OpenFeign. Okay, these were the two choices that were available in the older versions of Spring Boot, right? But now things have changed, and there are other alternatives that are much more modern and recommended by Spring. So if you're working on legacy projects, okay, and if there is no plan of migration, you can continue working with RestTemplate and OpenFeign as long as there are no issues. But if there is any sort of migration ongoing, I would recommend that you switch over to the modern alternatives. And if there is any chance, I would highly recommend that you push for updating to the latest versions or the latest and the new REST clients. Okay, so that is one point that I want to mention. Legacy projects will have, of course, RestTemplate and OpenFeigns, and it's important that you have knowledge as to how you can work with them as well. But it's important that you switch to modern alternatives. So that is one recommendation from my end. So another thing over here is about synchronous and asynchronous need. Now for blocking calls where each HTTP call waits for a response, RestClient can be an alternative, and if you want to use the declarative style, you can make use of HTTP interface. It's straightforward and easy to use if you follow the right documentation. And if you need non-blocking reactive behavior, you can make use of WebClient, which is a modern choice, especially when handling high concurrency or IO bound operations. All right. Another point is about programming style and the developer experience over here. Okay. So if you want to make use of declarative approach over here, so you can make use of HTTP interface, and it lets you define clients with simple interfaces and annotations, reducing boilerplate code and making your code cleaner. Okay, so this is important, and yes, there are declarative approach in OpenFeign as well, but as per Spring, it's recommended that you switch over to the latest versions or the modern options over here. Okay. And you can even make use of WebClient and RestClient without HTTP interface. That's absolutely okay if that's the style you prefer. All right. Now, one thing to remember over here is that there is no one size fits all answer for this, right? And your choice would match your project requirements, your team familiarity, your long-term maintenance goals. Okay. So best practice is to start with the simplest options that meets your need if you're starting a new project, and then evolve with your client strategy as your project grows. Okay. So I would also like to point as to what Spring recommends right now. So if you come over here to the browser, this is the official documentation of Spring Cloud OpenFeign. Okay. And you can see over here, there is a warning that it says that Spring Cloud OpenFeign is feature complete. There are no new features that will be added into this project, and it's into maintenance mode officially. And there is an official blog announcement that they have done over here, which I have open over here. So it's with the Spring Cloud 2022 version, and I would request you all to take a look at this announcement. So they won't be adding new features to the module. Okay. And over here, you will also see the list of like the link to the Spring interface client over here. So this is the article over here, and you can see these are the 4 options with Spring. And you can make use of any of these. But if you take a look at RestTemplate over here, so if I select RestTemplate, okay, and you can see over here, so this is the right link. So if you search for RestTemplate class on Spring documentation, under class, you'll see this RestTemplate class. And here you can see clearly in the description, so it talks about what RestTemplate is. And here it clearly says that as of 6.1, this is a new version of Spring. And it says RestClient offers a more modern API for synchronous HTTP access. So you can make use of this, and for asynchronous, you can make use of WebClient. So switch over to these is what it's telling you over here. Okay. So RestTemplate, OpenFeign are options. Yes, a lot of projects are using it, but the recommendation is you switch over to these modern alternatives that exist over here. Okay. So it's RestClient, WebClient, with HTTP interface. So you can choose whether you want to make use of HTTP interface. It's a declarative style, like okay, but RestClient and WebClient are the 2 options. All right. So I hope this has been valuable, and I hope you have been able to follow along.